This is the screencast for section 3.3, example 6. We're going to work with numerical values. So in other words, if you don't know what a function is, you only know what the function is called, you can still take some derivatives and work with numerical values of those functions and their derivatives. So we're going to say that y equals u times v. And we want to find y prime of 2. Well, if y equals the function u times the function v, to take y's derivative, I need to use the product rule. So I'm going to use u and then times v prime, and then add v times u prime. Well, I've got numbers for those. So y prime of 2 is going to be each of these evaluated at 2. So u of 2 times v prime of 2 plus v of 2 times u prime of 2. So y prime of 2 will equal, you see, u of 2 is 3, v prime of 2 is 2, v of 2 is 1, and u prime of 2 is negative 4. I don't know why I put that in parentheses, but I did. So that is 6 minus 4, so 2. The now try problem number 23 says u and v are functions whose input variables are x, and they're differentiable at x equals 0. It gives us some values of u and u prime at 0, and v prime at 0, and we're supposed to find the values of the following derivatives. So the derivative with respect to x of this u function that has x as an input variable times the v function that has x as its input variable, evaluated at 0, would be, let's see, product rule again. So u prime of 0 times v of 0 plus v prime of 0 times u of 0. U prime of 0 is negative 3, v of 0 is negative 1, v prime of 0 is 2, and u of 0 is 5. So I have 3 plus 10, so 13. Now part B asks us to find the derivative of the quotient of those two functions whose input variable is x. So if I use the quotient rule on the quotient, I will get, let's see, the denominator, start with the denominator all by itself left alone first, and then multiply by the derivative of the numerator, minus the numerator times the derivative of the denominator all over the denominator squared. Plug in some numbers, each appropriate number, and I get negative 7. Now part C, I'm still taking the derivative of a quotient, but this time v is in the numerator and u is in the denominator, so it's going to look different. I'm going to start out with the denominator, which is this time u, left alone, times the derivative of the numerator, which they're calling v this time, minus vice versa, so u prime of 0 times v left alone, all over the denominator, which is this time u, squared. Plug in my numbers, and I get 7/25. So in other words, the slope of the tangent at x equals 0 of the v function divided by the u function would be 7/25. Part D is a little bit longer. I'm taking the derivative of the sum and difference of these functions of x, and they've got some coefficients, and there's a product in there. So, all right, we'll take this step by step. The derivative with respect to x of 3 times the u function, we've got a property that says we can just leave 3 out in front of the function and take its derivative. So the derivative of u is u prime, and we want to evaluate that at 0. Then we have minus 2, same thing, I can leave this coefficient out in front and then just take the derivative of the v function, which we don't know what that function is, but we can symbolize it by doing v prime of 0, plus, now I'm going to leave that coefficient out, but now I have to work with the product rule. So in these brackets, I'm going to use the product rule with u times v. Okay, so there we go. I'm going to plug in some numbers. So I've got 3 times the derivative of u at 0, which is negative 3, minus 2 times v prime at 0, which is 2 from the directions, plus 2 times this whole mess in here. So u prime evaluated at 0, which is negative 3, times v at 0, which is negative 1, plus v prime at 0, which is 2, and then u of 0, which is 5. So I get 13.